Separable equations. A differential equation is called separable if we can write this as a product of two functions, one in terms of x and the other one in terms of y. For example, dy dx equals y sine x, where f of x is sine of x and g of y is y. And so it is a product of two functions f of x and g of y. If it is separable, we can separate the variables. That means that we're going to rewrite the variable y in one side and the variable x in the other side. And then we integrate each side. The left-hand side, the integral is ln of y, and the right-hand side, the integral is negative cosine of x plus an arbitrary c. We then isolate y by e both sides of the equation. So y is e to the negative cosine of x times e to the c power. But e to the c is a constant, so oftentimes we rewrite it as a e to the negative cosine of x. As long as we can write the differential equation as a product of two functions, one in terms of x, the other one in terms of y, and as long as we can find the antiderivative of the left-hand side and the right-hand side, then we can isolate y to obtain the general solution to the differential equation. Now we're going to justify what allows us to separate the variables. Suppose we have dy over dx equals f of x times g of y. If we let g of y equals 1 over h of y, then we can rewrite dy dx as 1 over g of y dy dx equals f of x by dividing both sides by g of y. And then 1 over g of y is now h of y. So we replace 1 over g of y with h of y. But y is a function of x, so y equals y of x. So dy over dx is y prime of x. Now we're going to rewrite the previous equation as h of y of x, and dy dx is now y prime of x equals f of x. And then we integrate both sides of the equation with respect to x, which is what we're allowed to do. This can be rewritten as the integral of h of y of x dy equals the integral of f of x dx, because dy over dx is y prime of x, so y prime of x dx is dy. But h of y is 1 over g of y, and so the left-hand side is the integral of g of y dy, and the right-hand side is the integral of f of x dx. And this is precisely what we did. We move all the y terms on the left-hand side, and we move all the x terms to the right-hand side.